Thanks for joining us today. I'm Jason with Net.Academy /LA Networks. We're kicking off a new series today, BGP. While everything we do here at Net.Academy is meant to be practical and hands-on, with BGP, we do have to go into some theory behind how the protocol was even conceived so that you can get the most out of utilizing it and having operational readiness. If you enjoy the content we have here, please consider giving us a like and a subscribe. Also, this is meant to really be a community. So if you have questions, please drop them in the comments below, or my email's on the screen. Feel free to email me. I'll do my best to get back to you. Quick caveat, while BGP is an industry standard protocol, it's used by all vendors really pretty much. We will be focused mostly on Cisco BGP, mostly because that's my background, right? I'm a CCIE. I cut my teeth learning BGP on Cisco routers. And, although today I might do BGP on cloud networks like AWS or Azure, I might do them on Cisco routers, or I might do them on Arista routers or anything else. The bulk of my experience is in Cisco, so I'm going to be a little Cisco-centric on here, and I think that's okay. Let's go ahead and get some of that background information, right? So you need to really think about where BGP came from and what its intention was. And the first thing to keep in mind is it was really built to solve the problem of large-scale inter-domain routing and loop avoidance, right? So if we were going to have a large network of networks, the internet, a network of networks, where every routing domain was independent of one another, right? I've got this ISP, this ISP, this ISP. Once in a while, I've got a university back in the early days. I need to make sure that I'm scalable because it's going to be huge. I need to make sure that I'm really strong with intradomain routing capabilities, and I certainly don't want any loop avoidance. I achieve these things by valuing accuracy and scalability over speed, right? If it takes me a while to converge, that's fine. If it takes me a while to determine a neighbor's gone down, that's fine. I'd rather be accurate and scalable. Also, in BGP, our updates are typically made using TCP, so it's a reliable update mechanism, right? As mentioned, we have very strong service provider roots when we talk about BGP, although I want to be very clear, for the last probably 15 plus years, we've really seen enterprise influence BGP just as strongly as service providers. In fact, over on Cisco, we typically have a different set of routers for service providers running different code, iOS XR, versus for enterprises, iOS XE, right? So they've really said, well, I've got different needs for both. So let me maybe get some different operating systems that prioritize different things over the other. When it comes to that interdomain routing, I have a very strong need for strong policy. I want to be able to determine I want to have a lot of granularity when I'm picking which ISP I want to go to, right? If I'm an ISP myself, I might have contracts with dozens of other ISPs, but not every contract is the same. Maybe some are preferred over others, or maybe it's more likely it's a lot more complex than that. So I need a strong policy-centric approach to routing, and that's exactly what BGP gives us. When I say direction matters, what I really mean is I can typically set nice granular policies, both inbound and outbound, independent of one another, which is pretty nice. Just some facts when it comes to internet, which was the original intention of BGP, right? And we want to keep that in mind. I grabbed a few facts from cider-report.org. Okay. So, and this may be pretty out of date depending on when you're watching this, but the total number of public autonomous system numbers is around 77,000 currently, a little over that actually. current total number of ASNs with just a single prefix is about 27,000. That means there's over 50,000 that have multiple prefixes, but 27,000 is still a lot that have single prefixes, right? And then total size of the internet routing table, over 1 million routes, right? That's a huge routing table when we think about 100 routes or 1 million routes, right? And if you would like a copy of these slides, please just go ahead and let me know. I'd be happy to help you out. Okay, we're going to end by talking about ASNs, and the next session, we're going to go deep onto ASNs. But an ASN just stands for Autonomous System Number, and it's basically a number that is used to represent your autonomous system to the rest of the internet or to the rest of the enterprise if you're running it privately in your own enterprise. Let's dive right in. So first of all, if you want to connect to the internet, you're going to need a public ASN. Public ASNs run from 1 to 64.511. And we'll get into those on the next session. And then private ASNs, think of it almost like private IP space, like the 10.0.0.0/8 address space, right? Private ASNs don't route on the internet typically, all right? Instead, they're used when we want to do designs that are going to be more using BGP for my enterprise protocol. If people are interested, we can go through some kind of overarching high-level designs and architectures, and we can dive deeper into what enterprise BGP might look like for things like WAN, right? We use BGP and ASN manipulation a lot in technologies like SD-WAN. If you're interested in that sort of thing, maybe give us a comment below. So in addition, if you want to connect to the internet, in addition to the public ASN, you're going to need a publicly routable block of IP addresses. You're going to need to register your ASN with something known as a regional internet registry, or RIR. Here in North America, I'm in Southern California myself, but here in North America, we typically use IANA. You may, depending on your situation, you may also be able to do this through your ISP. I wouldn't say I see it commonly, but I've seen it a couple of times where you actually use a private ASN, you connect to an ISP, and then you get a very small routable block and they aggregate it up for you. When I talk about a routable block of IP addresses, I'm talking at least a /24 in IPv4 space. Granted, IPv6, a lot of this goes out the window. I'm definitely not an IPv6 expert, so we're not really covering that today. But when it comes to IPv4, you can sometimes still pick up blocks from your ISP. What they do is they basically do a transfer, again, through an RIR, and they transfer, maybe not ownership per se, but basically autonomous system authority of that range from their organization to yours. And then they can take that back at the end of the contract or whenever. Hopefully this is getting you hungry for more, because I have quite a bit of content when it comes to BGP. So I want to thank you for taking the time today. And again, if you have questions, you can email me, or you can just put something down below. And again, if you enjoy it, maybe give us a subscription and a thumbs up. We would appreciate it a lot. Thanks so much. Have a good day now.
Need help? Call our cybersecurity team and book a consultation with us today.